Good evening, everybody. Welcome to Data Rave, and we're very grateful to be here in the offices of Huge, whom we thank very much in the person of Scott Wolf and Fern Diaz for allowing us to be here. Tonight's talk is by Mark Phillips, who is a longtime researcher in environmental science and other physical sciences. He has worked at NEMAC, the National Environmental Modeling and Analysis Center at the University of North Carolina, Asheville, and he's associated with something called the FernLeaf Interactive. Is that correct? FernLeaf Interactive. His topic tonight is a data visualization topic, visualizing climate data with JavaScript. Without any further trouble, I give you our speaker, Mark Phillips.
Thanks. So give me just a second to get things fired up here. Okay, so yeah, I'm going to talk about visualizing climate data using the web as a platform. And before I get started, I thought I would say just a little bit more about myself. As David said, I've been doing research in the area of climate data visualization for, I guess, about 13 years or so. Before that, I got into all of this through the fact that I used to be a mathematician, and I dealt with visualizing abstract mathematical concepts. And I did a lot of work with 3D graphics. I worked at kind of a unusual research center back in the 90s that focused on finding ways to use interactive 3D computer graphics to help people understand math concepts. And I first got started dealing with climate data through some contract work that I did for the National Climatic Data Center, which is part of NOAA, the National Oceanic and Atmospheric Administration, which in turn is the umbrella organization for the Weather Service, for those that aren't familiar with that. And for the last 8 years or so, I've been working at a research center at University of North Carolina in Asheville, North Carolina, called NEMAC, that basically does contract web development. It's a little different from most university research centers. We act mostly like a consulting company. We take on projects for clients and build parts of websites, basically. So before diving in and talking about climate data, let me also say that I'm not a climate scientist. The work that I do and have done ever since I've been in this has had to do with taking the research and the data from other researchers who are experts in the field and figuring out ways to present it and make it more approachable and understandable by both the public and other researchers who are in other fields. So I'm going to show the results of some data analysis that I did, but the analysis that I do is really just experimental and for the purpose of illustrating the software. But I'll say more about that later on. So I'm going to start by taking what I think of as kind of a geek's approach to climate data. And that is, if you're, I imagine a lot of people here are data scientists or work with data. And so let's suppose that you want to get some climate data and analyze it for whatever reason. Maybe you're just curious. Maybe you've heard a lot about global warming and you want to download some data and try to compute some trends and see if you can see what's happening. Where would you go to do that? Well, there are lots of places to get climate data, and you almost have to be a climate scientist to understand them all. But one place that has most of the data for the United States, at least, is the place with the logo on the lower left there, the National Climatic Data Center in Asheville, which is the place that NOAA archives all its data. And so I'm going to step through one little example of how to get some data from NCDC and do some fun stuff with it. So let's see. I'm going to start out with something that is probably familiar to most people here. This is obviously Central Park. And if you've walked in Central Park very much, you're probably aware that right here in the middle is kind of a surprising thing that, at least it surprised me when I stumbled on it the first time I was walking in Central Park. It's Belvedere Castle. If you may or may not have noticed, if you've been there, that up on the top of the tower at Belvedere Castle, there are some instruments. There's an anemometer for measuring wind speed and a wind vane for wind direction. And also, over in the woods, kind of across from the castle, there's a fenced-in area with a bunch of other instruments that measure other things like temperature and rain, and I'm not sure what all else. And I think I see an antenna there that's probably for transmitting the data somewhere. Where would you go if you wanted to get the data from that station? It turns out this station has been here since 1919, just clicking away, collecting data. And I think there was another station somewhere else in Central Park, I'm not quite sure where, going back into the 1800s. And so it turns out the place to go to get the data from this station is, like I mentioned, NCDC. The website is ncdc.noaa.gov. And I won't go through all the details, but if you go to NCDC's homepage, there's a link at the top that says Data Access, and if you start drilling in, you get to this page with various kinds of data, and we want land-based station data, because that's a land-based station there in Central Park. So you drill on down, and eventually you get to a list of data sets, and I happen to know that the data set that contains the data from that station is called GHCN. It stands for, I think, Global Historical Climatological Network, something like that. And so we drill into that, and finally we get to a link that says Data File Access, and we click on that, and that takes us to an FTP directory. So that was a lot of clicking, but eventually here we are at a place where we can download some files. And one of those files is called ghcndstations.txt. And so if you pull that up, you see that it contains a list of stations. And so the first thing we need to do is figure out, okay, which one of these stations is the one that we want. So you could search through here like I did for the word Belvedere, and you won't find it. But if you search for the word New York, you'll find that there's a bunch of them. And eventually, way down towards the bottom of the file, there's a line that says New York Central Park TWR, which you could imagine maybe is tower. If you want to confirm that that's the right station, you can notice that the second two fields on the line are the longitude and latitude, which you could take and paste into Google Maps, and it puts a marker right at that location, and sure enough, that's the spot. So that must be the station. So back here at the file, the first field on the line is the ID for the station. So that's the thing that we need to use to look up the data for that station. So back at the directory, I'm interested at the moment in just getting the last year's worth of data, or rather data for this year. So I'll go into the by year directory, and there's one file per year. It's a compressed CSV file. And if you scroll down to the bottom, there's 2015.csv.gz, and I can download that and uncompress it and look inside it, and you can see a bunch of lines that look like this. And it looks like the first thing on each line is a station ID. And if you search through it for the station ID that we're interested in, the first thing you find is this block of lines here that are all for the date 2015-01-01, January 1st. So there's the January 1st data for our station. So at this point, I'm going to just filter all that data out and put it in a different file. And I tend to use command line programs for that. You can use whatever you want. And I specifically wanted to look at the first line there. You can see it says Tmax. That stands for temperature maximum. So it's the maximum temperature for the day. So I want to grab all the Tmax values for this station and put them in a file together. And so I end up with a file that looks like this. So this is getting pretty close to something that's usable. I could load that into whatever plotting program I want, or read it into a statistical package to do some analysis or whatever. But one thing that's a little surprising, if you look at these numbers, 39, 56, those look like reasonable temperatures, but here's one that says 133. And I don't think it's ever been 133 degrees here in New York, but certainly not on January 4th. So something weird is going on. But if you go back to the FTP directory, you see there's a README file. And so at this point, it's probably time to actually read the directions. And so if you pop open that README file and scan through it for Tmax, you get to this line that explains that, oh, the units are tenths of degrees Celsius. And that's kind of weird, but anyway, there it is. Turns out the reason they do that is so they don't have to put decimal points in the file. It actually makes the file a little bit smaller. But anyway, so you can take those numbers and plot them, and you end up with a graph that looks like this. So this is the maximum daily temperature for Central Park starting January 1st up until a couple weeks ago when I made this slide. Now we could do the same thing for the minimum daily temperature, and we get another graph that sits under that, and that's kind of cool. You can sort of see the range of temperature for each day and see the warming that happens in the spring, but it's certainly not uniform. It kind of goes up and down. Another way that I like to display this daily max and min temperature data is with sort of a modified bar graph like this, where each bar corresponds to 1 day's worth of data, and the bottom of the bar is the low temperature for the day, and the top of the bar is the high temperature. So anyway, that's kind of a whirlwind demo of how to get some data from that station. But remember that when we looked at the list of stations in that file, the ghcnstations.txt file, there were a bunch of them in there. In fact, there's about 90,000 stations in there. What if we wanted to do this for all those stations? If you take the longitude and latitude for all those stations and plot them, you get a map that looks like this, which is pretty crowded. And doing that kind of data access and presentation is a part of what was sort of my job when I got started in all of this several years ago. I wasn't working with this particular collection of stations. Believe it or not, this is just one collection of stations. There are others. And there's sometimes overlap between them, but there's a lot, a bewildering array of weather stations in the world. But I was working, starting in 2002, with another network called the Climate Reference Network that is a new network. Most of those GHCN stations have been around for decades, if not over 100 years. This network is all completely new stations built starting in, I think, 2001 of extremely accurate, modern, very precise stations with redundant sensors. So the stations for this network, first of all, there's not nearly as many of them, but they're highly accurate. They have 3 different temperature sensors, 3 different precipitation sensors. They measure wind speed, solar radiation, which is basically sun brightness, and ground temperature, soil moisture, and soil temperature at multiple depths, and humidity, and several other things. And most of that data is being recorded every 5 minutes. So even just from one station, it's a huge amount of data. It's, I think, more than 2 million data points per year per station. And so you quickly get overwhelmed if you try to download all of that and put it in a plot. At any rate, my job was to figure out a way to give users access to this data and to make it easy to visualize. And since I had a background in interactive graphics, and I was used to looking at abstract mathematical objects on the screen and in 3 dimensions, or in some cases even 4 dimensions, and spinning them around and zooming in and out, I decided it would be fun to do something like that with weather data. And so I developed a program that eventually came to be called Multigraph, that allows for creating an interactive data plot in a web page. And I'll show it in just a second, but let me just mention a couple things, a couple of the guiding ideas that went into creating it in the first place. Like I said, I wanted it to be interactive. I wanted the user to be able to zoom in and out in the data and to look at just the part of the data that they wanted. I was inspired by the work that I had been doing in interactive 3D graphics, and I was also inspired by Google Maps. This project started back in 2002, and at that point, Google Maps was fairly new, and I don't know if you might remember, but I think Google Maps was one of the innovative things about Google Maps, as distinct from other web map applications, is that it was the first one that I remember that allowed you to grab the map and drag it. Before that, there were sites like MapQuest, where you would have an icon on each side of the map for north, south, east, west. You click on the icon, and then you wait for the page to refresh, and then you get a new view. And Google Maps added to that the ability to just drag it, and then it would fill in the data with more tiles or more parts of the map as you dragged. And so I had the idea of doing that with data graphs. So a part of that involved working out a way to have a service on the server to deliver the data so that the application could request just the parts of it that it needed when it needed it. Another criteria that went into it is that I was working at the National Climatic Data Center, which has a lot of scientists that work there, and they're not all programmers. And we wanted to make it so that non-programmers could create new graphs. And so part of the design had to do with just coming up with a way to make it possible for non-programmers to make new graphs, and I'll say more about that in just a minute. So here's a graph made by Multigraph, and let me switch over at this point to my browser and actually pull that graph up. And assuming my internet connection is working, we should get live data. So this is data from the Central Park Station that's being delivered live from a web service. So when I first pulled up the graph, it immediately went and got the last week's worth of data. But I can grab the graph and drag it, and as soon as I let go of the mouse, it does another AJAX request to get more data to fill it in. And so I can keep going back and look at more and more data. I can also do what's the equivalent on the trackpad here to the scroll wheel, a double finger slide, to change the scale on the horizontal axis. And then as soon as I stop, it goes and fetches more data to fill in. So now we've zoomed out and we're looking at, I don't know how long that is, but 2 or 3 weeks there. And we can keep doing this as long as we want. It'll keep fetching data and filling it in. So there's about 6 months worth, and so on. So here, let's zoom in a little bit right here. Here's an area in early March where it got warm for a while. I think I remember that. That was kind of nice. But at any rate, so that's just one little example of using Multigraph in a web page. Like I said, the original inspiration for Multigraph was when I was working with this network of weather stations that had lots of sensors. And so the original Multigraph graphs looked more like this, where in this plot, we're looking at several different values in one plot. The pink shaded area is solar radiation, sun brightness, basically. The blue dotted line is air temperature. And remember I said this station has 3 different temperature sensors, but this is basically a combined measurement that's more or less the average of the 3. The green bars are precipitation, and the black dotted line is wind speed. And let me switch over to an interactive version of that one. And sometimes the data service behind this one can be kind of slow, so we'll see if we get lucky and actually get data here. There we go. So this is, the last few days worth of data from, there's not a CRN station in New York City, but there is one in upstate, sort of near Poughkeepsie. And so this is data from the last few days of that station. And one thing that's kind of cool, if I back up a little bit, we can zoom in on the last few hours, and you can see a rainstorm that came through. And the same rainstorm came through here like a couple hours after that, which was sort of right as this meetup was starting. And I don't know about the rest of you, but I got drenched on the way over here. Anyway, let's see. Yeah, so I'm just going to go through real quickly a little bit of information about how to, what does it look like to put one of these graphs in a web page. In the simplest way, you just make an HTML file that loads in the multi-graph JavaScript file and creates a div object, and you point the div object at a file that contains a configuration description of the graph, and you give it a width and a height and a class of multigraph, and it makes the graph. So this is the HTML page for this graph of Central Park data that I was showing a few minutes ago. This data, this JSON file right here, contains a description of the graph, and it looks like this. And don't try to read all of that, but just sort of generally notice that it has a section that describes the horizontal axis, and a section that describes the vertical axis, a section that describes where to get the data. And so this is referencing a service endpoint. Oops. And then a section that, I lost my cursor. There it is. A section that describes the plot style and options and so on. And so by making one of these JSON files and feeding it to multigraph, you make a graph. So you could easily make another graph with different data by just pointing this to a different data source. So that's sort of the way that it's possible to make these graphs without doing any programming. If you do want to do programming and you want to do something more custom, you can do that. Multigraph acts like a jQuery plugin. So you can also just target a div with a selector like this and call the multigraph plugin and give it the name of the file that contains the graph description. And that'll do exactly the same thing that the previous slide did. Or you can create the graph description object dynamically and pass that in. And then that opens up the possibility to do all kinds of more interesting stuff, like here's a program that modifies the max and the min settings, or the initial max and min settings on the horizontal axis to always be the last week. So whenever the user pulls this up, it'll show the last week's worth of data. So let me pause at that point and just ask if there's any questions. Anybody have any questions so far? Yeah. This does not use D3, and I'll say more about the reason behind that in just a minute. Mm-hmm. It does the best that we were able to code. Sometimes you get pretty good error messages and sometimes not. Yeah. Yeah, that's a good question. So I have done plots with, I think, 40,000 data points. 40,000. It depends a lot on the machine that you're looking at it on. In fact, that kind of leads into my next slide, so maybe I'll go ahead and show this. The way multigraph works, so to do its drawing, it's using the HTML5 canvas. And nowadays, there's basically a choice of two ways to do interactive graphics in a web page. There's Canvas and SVG. And we chose Canvas because I wanted to have really fast rendering. And SVG is really great for a lot of things, but since it's adding elements to the DOM, it can be a little bit on the slow side. And so the way multigraph works, it's more akin to the way a 3D game works, or a 2D game for that matter, that you've got some concept of a state of the program, and then a method or function that renders that to the screen. And then whenever the state changes, so watch carefully, I'm going to advance to the next slide, and there, you see the state changed. So what happens then is the screen gets erased and then redrawn. And that happens every time anything changes. And so you want this render phase right here to be really fast. And with Canvas, it's faster than SVG. What also happens internally is that when Multigraph initially reads that configuration file, it does some pre-processing on it to cache a bunch of things that it needs, so that then when it does the rendering pass, it's doing the minimum amount of work that it needs to. And the amount of time that this render pass takes depends, for the most part, only on how many points are actually being drawn. You can load in a data set that has a lot more data. Like I said, 40,000 points. That's sort of the most that I've managed to have in view in the window at one time. You could have a data set in there that was 1,000,000 points, and as long as it's only actually drawing, you know, a few thousand of them, then it's generally fine. So, oh yeah, and so this stuff, the picture at the bottom here is just sort of by comparison, the way things work with SVG, where you have, you know, some sort of configuration or code that defines your SVG object, which is inserted into the DOM as nodes in the browser DOM. And once that's set up, it's great and it's really fast, and there's certain ways that can be tweaked. You know, like moving a group of objects by changing the transform on it. But if you want to do anything very general, like, you know, totally changing the coordinates or compressing an axis or something like that, then it needs to be, you end up essentially doing manipulation on the DOM, which is fairly slow. So anyway, that's sort of an overview of what's happening under the hood with the multigraph. D3 uses SVG. That's right. Yeah. Let's see. Let me get into this. So, Multigraph got started back in 2002. And on the topic of the D3 question, the other reason Multigraph doesn't use D3 is that D3 didn't exist until 2011. And what's happened over the course of the life of this project is we've rewritten it several times. In 2002, it wasn't feasible to do interactive graphics with JavaScript. Canvas didn't exist, SVG didn't exist, D3 certainly wasn't around. The only game in town at that point was Java, the Java applet. So the original version of Multigraph was a Java applet. And JSON didn't exist as a format then either, at least not as far as I know. Sort of the format that was in vogue at the time was XML. And so the original version of Multigraph read XML configuration files and was written in Java. And then several years later, Java in the browser started falling out of favor, and we experimented with writing it in JavaScript using SVG in 2008. But at that point, the performance that we could get out of SVG just wasn't quite up to snuff, and there were also problems with compatibility. It wasn't supported in Internet Explorer. And so we kind of abandoned that particular JavaScript attempt and decided to go with Flash, because around that time, Flash was sort of the going way to do anything interactive in a web browser. And so we had a Flash program that would read the same XML configuration files. And then several years later, Flash started falling out of favor, and there were all kinds of mobile devices that it didn't work on. And JavaScript had come a long way, and Canvas was well supported and fairly optimized, and so we rewrote it in JavaScript to use Canvas, and the configuration files were still XML at that point. And then just this past fall, I managed to carve out enough time to add the ability to read JSON files, which is so much more pleasant than dealing with XML. Anyway, that's sort of the rest of the story about the relationship with D3. If I was going to do the project now, I would seriously consider sort of trying to use D3 and do figure out if there's some way to kind of optimize the SVG. But we had started this long before that and had gone down a different approach and just had a lot invested in that approach. So the other thing that multigraph can be used for is, what I've showed so far is just putting a graph in a web page, but you can also use it as a component in a larger application. And our group has done several projects building larger applications that use multigraph, and so let me show a couple of those right now. So here's the location of all the stations in the Climate Reference Network, the group that I was originally working with when multigraph started. And this is just an interactive map application. It uses Leaflet.js for the mapping. So I can mouse over and see the names of the stations. I can zoom out and zoom in. And if I click on a station, it pops up a graph, a multigraph of the data from that station. And I can interact with that graph just like any of the other ones. So this is a quick way to kind of get an overview of the whole network and go directly to whatever station you want. Let's see, I think this is the New York one that we were looking at just a few minutes ago. So that's one example of multigraph in a larger application. Another example is, like I said, we do a lot of contract work for NOAA. This is the website climate.gov, and climate.gov is a relatively new website that NOAA started 3 or 4 years ago that is a little bit analogous to weather.gov, except the idea is that this is where people go to get information about climate rather than weather. The difference being that climate has to do with long-term trends. Down at the bottom of the screen is this interactive application called the Global Climate Dashboard. And the idea behind this is to let people see in comparison several different data sets that measure kind of the state of the climate on a global scale. And the idea behind this is everybody talks a lot about climate change, and the thing that you hear most about is a warming trend. But just pretend for a minute that for whatever reason we could not measure the temperature, but we still knew what temperature was, we just didn't have any way to measure it. But we suspected that it was warming. What are some other things that we could measure that we could use as an indication that the planet's warming up? So some things that come to mind are sea level, because when everything warms up, the water warms up, and when water warms up, it expands and rises. It also rises a little bit because glaciers and ice caps are melting, but it turns out most of the rise is due to thermal expansion. But at any rate, sea level rise is one thing. Melting glaciers is another. You could take pictures of all the glaciers with a satellite and measure their area. You could take pictures of the North Pole and measure the extent of the ice cap in the winter or in the summer. And measure all those things. And it turns out all those things are being done, and there are official data sets that are kept and maintained. And the point of this application is to show a bunch of those in relation to each other. And so when it first comes up, it's showing global average temperature. And as you can see, it's getting warmer as things go to the right, or as time moves forward to the right. Each of these graphs is a multigraph, so the user can interact with this to go back or forward. You can also zoom in or out. One thing that's immediately obvious is that there's temperature data going back to, I think that's 1900. I think it actually goes back to 1880. The second graph is carbon dioxide, and that data doesn't start until the 1990s or 1980 or sometime around then, but that's because it was only just then that it occurred to people to start measuring it and recording it. This third graph is spring snow cover. And then there's these other data sets down here that if I click on them, it swaps the graph I click on in above, and the one on the bottom kind of rolls off. And so now we're looking at Arctic sea ice extent, and you can see that as we move forward in time, that's going down. Let me do one more. How about sea level? So sea level's going up. So at any rate, this is this is on the homepage of climate.gov, and its point is just to give users a quick way to get a sense of what's going on with some of these things. Yeah, that would be really cool. Yeah. There's a lot of talk about finding ways to make information like this so that people can actually relate to it better. That's important. Anyway, so that's just a couple of applications that we built using multigraph. At this point, I think I want to get back to the little experiment that we were doing with the data from the Central Park Station. So remember that, let's see, let me get back to the right slide here. Yeah, so remember we made a plot that looks like this of the daily high and low temperatures, and we could zoom in and out and look at a week or a month or a year or several years. What if we wanted to look for trends in this data to see, has it actually been getting warmer here in New York over the time period that station has been there? What could we do? Well, one naive thing to do is just to plot all the data, and if we do that, we end up with a graph that looks like this, which is not terribly useful. You can see a little bit of information from there. You can sort of see what the highest of the highs are and the lowest of the lows, and if you blur your eyes, you can sort of imagine that maybe it looks like it's increasing to the right, but it's really hard to tell anything. And so what I did, just to see what I could do, is to say, well, the data obviously cycles on an annual basis, so let me compute an average each year of what the Tmax was for that year, and then do the same thing for the Tmin. So then I would get new data sets which are annual in granularity instead of daily. And so if you do that and you plot the resulting graphs, you get something that looks like this, and I'll take away the daily values. So this is now, it's a little bit hard to say, but it's annual average of daily maximum temperature is the top graph, and the bottom one is the same for daily minimum temperature. And so the question at hand is, can we see a trend there? And the way that I know to try to look for a trend is to compute a trend line, a least squares fit trend line. And so if you do that, you get something that looks like this, and it's two different lines because it's two different time series. And they look like they're going up to the right. If you actually print out the slope, you get these numbers. And if you multiply that by 100 to get a rate per century, you can see that, okay, according to this little analysis, it looks like New York is warming at a rate of about 2.5 degrees Fahrenheit per century in terms of the maximum temperature per day, and the minimum is increasing at a rate of about 2.2 degrees Fahrenheit. So that's cool. That's interesting. But remember now, this station is one of 90,000, right? What if we wanted to do the same thing for all of those stations and then somehow look at the results? Well, that's in fact what I wanted to do. And so, so let's see what's involved in doing that. The first thing you notice if you download all this data and start plowing through it is that it's very sketchy. There are a lot of stations that didn't exist for very long. There's a bunch of stations that, given any year, you'll find a bunch of stations that came into existence that year and then stopped. So they've only got data for 2 months in 1931 or whatever. And it's not very meaningful to consider that data when what you're looking for is a long-term trend. And so you need to apply some sort of filtering to the data to decide what data to look at. And so what I did, which is by no means the right thing to do, and like I said, I'm not a climate scientist, this is just an arbitrary decision that I did as an example in putting this talk together. But I said, okay, I'm looking for long-term trends, so I'm only going to consider stations that have a lot of data for the last, well, yeah, the last half of the 20th century. And what I decided I meant by a lot of data is data for 90% of all days in the period from 1950 to 2000. So any station that was missing more than 10%, I just threw it out. And that whittled the number of stations down from 90,000 to 2,100. So then I computed the annual average of the Tmax and the Tmin for each station, but also taking into account that a lot of times you'll have a station that maybe it's got 100 years worth of data, but there are periods when the station was broken for several months. And so if in one particular year the station sat there and didn't produce any data in the winter, if you made the average, computed the average for that year, it would be too high. It's not representative. And so another filter criteria that I just sort of arbitrarily chose is I'm going to eliminate any year where there's more than 7 days of consecutive missing data. So that guarantees that I've got data spaced somewhat evenly throughout the year. It's still not a perfect thing to do, but it was just an easy thing that I did sort of as an experiment. So, so I did that and computed all the slopes and colored the station by slopes and came up with a plot that looks like this. And I put this in an interactive app, so let me switch over to the live version of it now. So here it is. So these are the locations of the 2,100 or so stations, and they're colored by the slope of the Tmax trend line. And so the redder stations, the slope is more positive. The bluer stations, the slope is more negative. And as I mouse over the stations, these little trend lines that are shown in these black inset graphs change to show the data from that station. The top graph, the red one, is the Tmax. The bottom one, the cyan one, is the Tmin. And then the white one in the middle is just the average of the two. And then this other graph right here, what that's showing is just the trend line, but with its slope magnified by a factor of 10, just to make it easier to see the direction that it's sloping in. So what's interesting is there are a lot of stations like this one where the maximum temperature is going down, but the minimum is going up. There's also a bunch where they're both going up pretty steeply. Let's zoom into New York and see what's happening here. So there's the Central Park. So what's happening here is pretty uniform. The minimum temperature and maximum are both doing the same thing, which makes sense. We sort of saw that when we looked at the numbers before anyway. One of them was 2.2 and one of them was 2.5. Oops, let's see. But one thing to notice here, or actually before I get into that, let's go back to New York. So what's going on here is this is an interactive map using the leaflet map library. These two graphs I did with D3 because I didn't want these graphs to be zoomable. These are just like little infographics that are really easy to do with D3. But if I click on this icon up here, it pops out a multigraph with the same data that showing both the, not the trend line, but the average that I computed along with the actual daily data. And I can zoom in and actually drill in and look at the individual daily values, or zoom out and look at the whole thing. And you'll notice somewhere right around there, it seems to switch. What's going on there is it's actually switching to a different data set that's by month. It's not a different data set, it's the same data set, but it's only taking one value per month. So as to cut down on the number of data points that it has to render. So anyway, this is just a way to explore the data and try to better understand what's happening with whatever trends there are. let me zoom back out to the whole country, and you might have noticed that there's kind of a surprising thing going on here, or at least it was really surprising to me, and that is that there's a huge region here in the southeast and the Midwest where the stations are blue, which means it's cooling off. Or at least that's the case with the Tmax trend. I can switch it to color the stations by Tmin by hitting a key on the keyboard. So now it's switched and the coloring is by Tmin, but it's sort of the same trend, or the same general pattern, that there's this region here where, I mean, there's some red stations in there, but most of them are either white or blue. So the general pattern is that it doesn't seem to be warming up as much in this part of the country. That is actually, I think, pretty close to the truth. So it turns out this is a well-known phenomenon. This was surprising to me because I'm not a climate scientist, but when I started asking around, the scientists that I talked to said, oh yeah, that's called the southeast warming hole. And if you go to Google and you Google the phrase warming hole, you find an article on climate.gov that talks about the question, does global warming mean that it's warming everywhere? And the answer is no, it doesn't. There are pockets where it's not warming or not cool, or where it's actually cooling. And right here in the Midwest and southeastern part of the United States is one of those pockets. There's also one out over the Atlantic Ocean, but overwhelmingly across the whole planet, the trend is, for the most part, warming, and in fact, warming a lot more than even the fastest warming parts of the United States. And so I'm not quite sure what the moral of the story is, except that you have to be really careful when you do analysis on climate data. It's tricky business. There are people whose whole career has to do with figuring out what the right analysis to do is and how to present it. So I think that's about all. Yeah. This is my contact information and some links of some of the things that I showed, and I'm happy to hang out and chat more or answer questions. Mm-hmm. Making the data more well, one project that we were involved in is something called the Climate Resilience Toolkit, which is a website that I might be able to pull it up here real quickly. Well, in general, first of all, the first answer is in general, the website climate.gov, sort of the whole inspiration for this grew out of a branch of NOAA that's charged with trying to educate the public and make the information approachable. And so this whole website sort of has that as its goal. One of the projects that we did along with that was kind of a companion website called the Climate Resilience Toolkit, which is toolkit.climate.gov instead of www.climate.gov. And this website is basically a collection of a bunch of stories, these taking action stories. It's sort of like a news magazine, and new stories are being added all the time. And each of these is a little, 2 or 3 page news article about some business owner or community or municipality or region that took some step to better prepare for the way the climate's changing. And it's a description of what information they had, why they made the decision, who they talked to, maybe some information about how much it cost, and so on. And one little example is somewhere down here is one that I'm familiar with. Yeah, this one. there was a restaurant on the Jersey Shore that was pretty much destroyed in Hurricane Sandy. And the owner had insurance coverage, and so was able to rebuild, but decided to go to the extra expense of raising the restaurant up on stilts. And so that was a hard business decision to make, because it took longer before he could reopen, and it was a lot more expensive, but it was one that he decided was, in fact, a good business decision. And so this is just an article about that decision process. So I don't know if this really gets at what you were asking about, but the point is to try to describe sort of real life situations where people have used information from this data to make decisions. Yes, there are. I'm not familiar with what all is out there. There's unfortunately, there's a ton of things like that that are made by all kinds of different groups. My familiarity is limited to the stuff that my group has done and a few related things. One of the things that's on this website is there's a tools section that's sort of an index of a lot of tools, sort of like what you're talking about. I don't know if any of these specifically have to do with emissions, but they're all interactive tools that let you explore some kind of data. Excuse me? Sorry, how does NOAA use what? The GHCN data? Well, a couple of answers come to mind. I mean, the main thing that the group that I work with does with it is they're the custodians of the data. They simply sort of are in the business of collecting the data from all the stations and populating those files in that FTP directory. But there's also a group that does research on looking for trends, like, sort of the little Mickey Mouse analysis that I did. They're real scientists that do it for real. There's a huge effort put into trying to figure out how to adjust the data to account for things like changes of equipment. And none of what I did takes any of that into account. But what happens if you look at 100 years of data from any one station is that it wasn't the same thermometer the whole time. And whenever they swap out the thermometer, it's calibrated a little bit different, and there's a little jump in the reading. And there's a whole science behind trying to figure out where those jumps are and how to adjust the data to account for that. There is. Some of the stations in that data set are outside the United States, and there are other data sets that are similar that include more stuff from outside the United States. Most of my familiarity is with the U.S. stuff.
Could you tell us about the use of multigraph? Can I use it?
Yes, you certainly can. Thanks for asking. Yes, and that reminds me, I have a slide that I somehow glossed over. Somewhere in here. It is open source. There's a website, multigraph.org. It's out there. Anybody's welcome to use it. Its use is fairly limited to our group and people that we've interacted with. It's been funded by the specific projects that we've done, and we focused on optimizing it for the things that we do. So it might suit what you want to do just great, and it might not, but I always love talking about it, so if anybody wants to use it, get in touch. It's kind of spotty. It depends on what the projects are that we have funding for. Yes. Yeah, it's on GitHub, and if you go to this website, there's a link at the bottom to the GitHub repo. Yep. No. I have tinkered with WebGL because I used to do OpenGL, and it'd be really cool, but I haven't.
You know offhand whether the user base of the government web pages have browsers?
I think I could say I know offhand that they do not. One of the banes of our existence for years with Multigraph is that all of our users at the Forest Service were glued to IE7. And I think that that's not quite true anymore, but I doubt that they have a browser that will speak OpenGL or WebGL. It's not standardized in the sense that it's an open standard that anything else uses, but it's documented, and it's pretty simple. It's just that's right. Yeah.
Sorry, it's not related to this, but does the standard measures actually define what the calibration for each thing, like the thermometers, they have to be as per the standards of standard measure or something like that was an organization? I thought all thermometers were calibrated to that, so like some cases Fahrenheit, same.
You're talking about what I was saying with the when a sensor is swapped out and it's calibrated differently.
But I thought all thermometers are supposed to be calibrated as per the standard.
Yeah, they are, but they are, but it isn't perfect. Yeah, I mean they are standardized in the sense that they all use the same scale, Fahrenheit or Celsius or whatever, but they do, but and I think that's gotten better recently. But in some cases, they're dealing with data that was recorded back in the 1800s, or back before there were standards like that. And yeah. But even now, if you take two sensors and calibrate them the same, that doesn't mean that they necessarily agree 100%. There's always, they're physical objects that are always subject to just their own unique variations, and and hopefully it's all very minor. But if you're recording, down to that level of precision, which some of the stations do, then you have to keep that sort of thing in mind.
Regarding the back end of format,
Mm-hmm.
it's expecting, is it just CSV?
Yeah.
Does it have any way of requesting specific subsets of the data from the back end?
So the format is the format of the response to the request is just CSV, and the format of the request itself is just sort of a RESTful syntax where you pass in the beginning date point and an ending date point, and then the response gives all the data between those two date points.
Okay, so it selects based on single whatever the x-axis.
That's right. Yeah, it's selected based on the x-axis. Yeah. There's one independent variable, and then any number of dependent variables along with it. Yep.
I'd like to return to the question of contributing to Multigraph and just ask you, are there features that you're still hoping to see developed? Are there areas, is there functionality that it doesn't have now or that you'd like to improve that might be attractive?
Yes.
Tell us a little bit about it.
Yeah, so one thing that comes to mind immediately, well, the most recent thing I was able to finally do, and that is to add the ability to deal with JSON and to finally be rid of XML. That's done. Another thing is, remember I said at the beginning that Multigraph was designed to be usable by non-programmers. So the original idea is you write one of these configuration files, or better yet, you get one that already exists and modify it a little bit to make your new graph. But then as time went by, we had more and more situations where we actually wanted to do coding with it. But the code is written in such a way that although you can kind of drill in and get access to the objects and methods and deal with them programmatically, it's not a very clean API for doing that. And so the code needs kind of a good refactoring to give it a cleaner API to make it easier to do that kind of coding. So that's probably the biggest thing that comes to mind at the moment. The little trick that I had that one graph doing where it switches from one data set to another as you scale in and out, that's not built into multigraph. I coded that in the page that creates that multigraph. You can register event handlers that say, okay, whenever the scale changes, call this function. And so that's the way that graph works. What would be really nice would be to add that as a feature to the program so that you could just put in the configuration file the fact that, okay, for these ranges on the x-axis, I want to display the daily data. For these other ranges, I want to display the monthly data, and just have it switch automatically. That's the feature that people have asked about. Well, so the data itself, just the values, it's just CSV. Well, wait a minute. Let me back up. The data, when you're referring to the format that's delivered by the back-end data service, is CSV. In the JSON, it's just an array of data points, like you would expect in JSON data. The conversion happens inside the program. That's right. That's right. Yeah. Yeah. Anything else? Yeah, so you don't have to use the back-end service. You can, and it turns out in practice, a lot of graphs, like for example, the Global Climate Dashboard application that I showed, there's no back-end service involved there because the data sets are, it's annual data. There's one value per year for 100 years. So it's just 100 data points per data set. So you could point it at a static CSV file. Yeah. Or you can just embed the comma-separated data in the configuration file.
Is there any, I know there's a whole trend in maybe like a bar chart principle into a different chart based on whatever a user wants to see. Is there any idea of maybe like
like a bar chart transforming into a line chart or
yeah, based on there's one example where you might want to have, instead of all those data points, like it becomes very cumbersome, like if you show them the data that was shown by the attention building, at one point it was unreadable, like we saw.
Right.
Better just instead of having in it like embedded lines and just transform into a chart.
Right. There's nothing built in for that. You can do the sort of thing that I was mentioning a minute ago where you can register callback handlers for different events. An event gets fired inside multigraph every time the user changes anything. And so you can sort of use those hooks to write code that goes in and manipulates the graph in whatever way you want. But there's nothing sort of built into the program itself to do any of that in an automatic way.
Well, I mean, like you're saying, you've been working on visualizing data for many years. You went through various iterations. And then you also said that your approach for your kind of data seems to be faster than the D3's SVG approach. If D3 was trying to do your kind of data, better off rewriting that aspect of D3 to go directly to the canvas? Or can you write D3 in that mode and then avoid system?
The bottom line is I think I don't know the answer to that, but my hunch is that there could be ways of sort of optimizing the SVG graph that D3 creates by doing some really fancy things where you've got kind of your representation of the data that's being plotted, and that gets transformed into an optimized SVG thing. A little bit like, I don't know if anybody's familiar with the Facebook React library that maintains a virtual DOM and that has great success at optimizing the render time in the browser. Something like that could be done with an SVG graph, and I kind of think that's probably the best approach, kind of given the current state of technology. But I haven't tried that. Yeah. I was just going to say, I'm happy to hang out and chat for as long as our hosts will let us stay, but maybe at this point I'll put the mic down and declare the talk officially over, and we can just hang out and keep visiting and talking.
Well, thanks to our speaker, and thanks also to our hosts. And thank you, those of you who are going to speak in the future, if you'd like to, here. Email me or Nick Collins. You can find us easily on the web, care of the meetup. We're looking for speakers who have something interesting to say, and it seems like a number of you do. So anyway, thank you for coming. Please let us know if you'd like to talk, and thanks once more to our huge friends. Good night.